Okay, welcome everybody. Welcome to the first seminar on computational educational sciences. My name is Dmitry Abakumov, and I am the seminar chair today, and for the future our seminars I will be the chair. Our seminar hosted by the Center for Computational Educational Sciences of HEC University, Moscow, Russia, and the Open Lab for Psychometrics of Digital Learning, which is the Open Lab which works around the world. The seminar is aimed at building the research community and thinking together on challenging problems on the intersection of education, quantitative research, and computational science. The seminar will take place on a regular basis, and me and my team, our team, will do our best to make it every month. And today I am very happy to welcome our first speaker, Carlos Rodriguez. Carlos has recently successfully completed his doctoral school in educational sciences at one of the best world universities, ranked top 45 in Times Higher Education ranking, and the most innovative university in Europe, KU Leuven, Belgium. Currently, Carlos is waiting for this coronavirus crisis to go away, and I wish it to be happen soon, to make his public PhD defense at KU Leuven. And today we have not only the great speaker, but we have the exciting topic, an artificial neural network analysis of academic performance in higher education. But before welcoming Carlos at our virtual stage, I would like to inform you about the seminar plan. So we will start with a 30-35 minutes presentation from Carlos, and then we will have around 40-45 minutes for questions and for open discussion. So we have this amazing software, Zoom. So, and we can use two options to ask questions. So the first option, you can use the raise hand button. You can see it near your picture. Yeah. And me or my colleague Елизавета Землякова, who is like a secretary of the seminar today, we will give you the virtual microphone. And second, you can ask the question in an open chat, and I will voice this question. Yeah, and now we have, this chat, and Daria said hello to everyone. Hello. So, okay, and now please join me in a warm welcoming Carlos at the virtual stage. Carlos, we are very happy to see you today. Please welcome.
Thank you very much, Dimitri, and good afternoon, everybody there. Good morning from Colombia. I'm greeting you from Bogota at my place, and well, I'm really happy to be here today with you guys. I really want to say thank you to Dimitri for this wonderful invitation, and I really hope that this seminar continue growing in the near future. I'm totally sure that it's going to be a nice opportunity to share knowledge and to get to know other person's work. So I think so. As Dimitri told you, today I will present you a section, like a chapter of my doctoral dissertation. The title of my doctoral dissertation is an artificial neural network analysis of academic performance in higher education. So today I have organized my presentation into three major sections. In the first part, I will provide a brief introduction to the use of artificial neural networks in educational research. In the second part, I will highlight like the most important aspects of the study that you had the opportunity to read. And in the last part, I will be more than happy to discuss with you and to answer any possible questions you may have. So let's begin with the introduction. I think it's always important to start from a theoretical perspective every time that you want to develop any predictive model. And of course, in the case of higher education and academic performance in higher education, there are several theories that have been postulated to explain how different characteristics of the students and how different experiences of the students can be considered as predictors of their academic performance in university. And I think it's a major criticism to the predictive models in higher education that they often lack of a theoretical perspective. However, it's not always the case, because as I told you before, we do have at least three important theories, three well-established theories, in order to select some predictors or some variables which are predictors of academic performance. It is also important to understand why we need to analyze academic performance in higher education. And I'm totally sure that you all agree with me that there are several important reasons to perform such an analysis. Here I present at least four major, four important reasons. And of course, it could be more reasons than these ones. However, I want to say that this analysis could be of benefit not only for students, of course, but also for teachers, but also for policy makers. And it is quite important to begin to consider different approaches, different ways in order to effectively predict academic performance in this sector, in higher education. So the question here is, do we need a different approach? And probably the answer is yes, we do. Even though the classical statistical techniques are powerful and are well known, and I will say that every quantitative researcher is aware of these statistical tools, these tools also face several challenges and several limitations related to the sample size, related to the statistical assumptions. It's not always that easy to have like a normal distribution in your data, for example. It's not always that easy to work with categorical predictors. And even though there are a lot of transformations in order to deal with categorical predictors, probably is not the best. So classical techniques definitely have several important limitations when we are trying to analyze academic performance in higher education. It is also important to know that students' information is increasing, and I think this is a reality that we are facing right now, because when the students develop online activities, for example, when students take part of an online course and so on, there is a lot of information related to their performance that we need to not only to collect, but also to analyze, right? And every single time we are having more information related to the students' characteristics with the students' experiences as well. So the volume of information that we are having now in relation to students' performance is bigger, is larger, and we definitely need to do something with that information. And that increase in the information related to students' performance means that every single time we are having more complex patterns of information that need to be analyzed. And of course, we need to explore something different, something new, in order to truly discover the information which is underneath those patterns of information. of those patterns of variables, right? So I think it's also quite common to listen to terms like big data, machine learning, artificial intelligence, and we do have nice examples coming from other disciplines such as marketing, engineering, business administration, and so on, of the use of these techniques in order to analyze and in order to develop predictive models. Even though the first types of neural networks were proposed, I don't know, like even 25 or 30 years ago, or even more, in the educational research field, you are beginning to understand what can we do with neural networks, which are the advantages of using neural networks, and so on. So even though this is quite known in other disciplines, in educational research field is something novel, and is something that deserves a lot of exploration, definitely. I think the best way to understand the use of artificial neural networks in educational research is to consider three words, right? Well-known words. So the first one is the computer science, right? The second word is education, and the third one is statistics. So if we make the intersection of these three words, we obtain what is called the educational data mining. And within the educational data mining, there is something called machine learning, right? And basically, machine learning refers to learning from examples. So you select or you have a data set. That data set relates several inputs with a specific output. And your main goal is to propose a predictive system which is capable to learn from that examples, and that's it. I mean, of course, in a simple way, you can define machine learning in that way. And of course, within the machine learning world, there are different techniques, different tools. One of the most used tools within machine learning is artificial neural networks. And I really like this definition, and I really want you to remind this definition of educational data mining, because it gives like a structure, and it gives a context in order to understand where the neural networks come from, you know, because it's also quite common to use these terms like machine learning or artificial intelligence or neural networks. But of course, there is like a hierarchy in these terms. So I think it's quite important to provide this framework in order to locate the neural networks. Now, our question should be, what is a neural network? And of course, if you search for a definition of neural network, I'm totally sure that you will find a lot of sophisticated definitions. I think there is a general tendency in the literature to define a neural network in terms of the brain structure. And it's quite common to read these definitions, which try to resemble the brain structure when they define a neural network. But personally, I believe that the human brain structure is much complex than the structure of a neural network. So I really don't like these definitions of neural networks, which includes like is a representation of the human brain and so on. There is also a general tendency to believe that neural networks are complex black boxes when you only obtain a fantastic prediction at the end, but you really don't know what is happening within that black box. And I think nowadays we do have evidence in order to refute also that definition of black box. So basically, I think that we can define a neural network in terms of the most simple element which defines the network, which is a neuron. And if we want to be if we want to be more technical, we can say that each neuron represents a mathematical function, as you will see in some minutes. So basically, we can say that a neural network is a set of mathematical functions that you connect following a set of rules, of course, and you connect those functions in order to perform a specific task. It could be a classification, it could be a prediction, it could be a clustering, right? But I prefer this definition, to be honest, that a neural network is precisely that, a set of mathematical functions which are interconnected or we are connected in order to develop or to perform a specific task. In the most simple way, this is like a neuron. Oh, this is a neuron, sorry. So basically, each neuron receives a set of inputs. There is like a summing block within each neuron. Then the resulting sum goes through an activation function, an activation block, and you obtain a specific output. So basically, each neuron, as I told you before, it could be seen as this mathematical function which has two blocks, that summing block, that threshold or that activation block, and that's it. So when we connect several of these neurons, several of these mathematical functions in this type of arrange, we obtain a neural network. There are three elements which define a neural network. So the first element is the way in which these neurons are connected. And it is normally called like the topology, the architecture of the network. The second element, which is quite important, is the way in which the network obtains the weights among the neurons, because there are specific rules, specific ways in order to obtain, to connect those neurons. And the third element which defines a neural network is the activation function, which refers to how the network is capable to transform the input or the inputs into the desired output. In the particular case of the study that we are discussing today, the neural network that which chose was the multilayer perceptron. And basically in the multilayer perceptron, what we want to do is to minimize an error function. So what we want to do is to compare the predicted value of the network to the desired value, right? And every time we make this comparison, we want to, of course, to reduce the difference among these two values, right? How do we do this? Basically, we begin to adjust the weights that connects the neurons in the network. In this particular case, we use something called a backpropagation algorithm. And as I told you before, it's quite important to understand how the network is capable to adapt, to adjust the weights which are connecting each of the neurons. So the backpropagation occurs in two stages, so to speak. In the first stage, the input signal is propagated from the input layer until the output layer, Then the comparison is made because we want to know that, or we want to be sure that the error between the real output and the predicted output is the less possible error. After that comparison is made, the signal is backpropagated from the output layer until the input layer. And in that process, the weights are adjusted and are modified in order to make that error minimum. And of course, there are several ways in order to work with this backpropagation algorithm. There are several ways in order to assess the quality of this process, and I will give you more information about this in some minutes. But I want you to also remind that for this study we chose the multilayer perceptron. This was the topology, the type of neural network that we selected. So in the present study, basically we had two objectives. The first one was to propose a methodological framework in order to solve some limitations, some drawbacks that have prevented the use of neural networks. And the second objective of this study was to illustrate the use of that methodological framework to classify academic performance in higher education. As I told you before, even though these analysis tools, I mean the neural networks, have been used in other disciplines, it is something really new in the educational research field. And that is why its use is still limited, I will say, because there are several methodological and conceptual issues regarding the use of neural networks, and probably there are still some educational researchers who still are doubting about the use of neural networks. So basically, what we wanted to show through this study was to, okay, if we follow a systematic approach and if we perform some specific task, we can show that it is possible to solve some of these limitations. So in order to provide a nice example of the use of the approach that we are suggesting, we selected a sample size, a data set coming from the educational context, the educational Colombian context, sorry. Our sample include, how many? Yeah. 162,100,030 students, Colombian students, of course. You can see like the main characteristics of these students in this slide. And it is quite important to highlight that here in Colombia, we have both private and public universities. And this was quite important because unfortunately there is a gap between the public and the private universities in Colombia. And our interest was also to explore and to understand how these SES characteristics and how these gaps existing between the universities could affect academic performance of the students. So, as I told you before, the type of neural network that we chose for this study was the multilayer perceptron. The multilayer perceptron can be used for classification or regression tasks. Our network had 122 inputs, one output. We selected the most simple architecture, so that's why we only work with one hidden layer. And an important decision that was made was the way in which we split the data set. So we decided to have like training set and the testing set, of course. But given the sample size and the sample size of the data set, we wanted to have more patterns of information in the training set. That's why it was of 80% of the total data set. Here in Colombia, and I think it's also important for you to know that here in Colombia, we have like a national standardized testing system. So basically, we apply several standardized tests at different moments of the educational process of the students. So, for example, at third grade, we apply a test, at fifth grade, at seventh, and so on. But there are two important tests that we manage and design here in Colombia. The first test is called SAVER 11. SAVER 11 is mandatory for all the students when they are about to complete high school. And this is a high stake test because many universities here in Colombia use the score of the test in order to admit a student. So it's like a requirement in the admission process of the students. And I think it's an exceptional case in higher education, the second test that we have here in Colombia, which is the SAVER Pro. And SAVER Pro is also a standardized test, but this test is taken by university students in Colombia. And even though we still don't take any important decision with the score of the test, I think it's a nice way in order to measure the quality of the higher education system in Colombia. And I think it's a nice way in order to understand how our university students are graduating from universities. So this second test, this SAVER Pro test, is taken by university students when they are about to complete their studies. And I am mentioning these two tests because these scores were our measures in this study. We also had another predictors in this study. So we had information about the tuition fees, how the students paid for the university. We had information about parents' SES, students' home characteristics, background information, age and gender, high school characteristics. We had information where the student was working or not. We had information about the university background. As I told you before, here in Colombia, we have this gap between private and public universities, which was also important to consider for this analysis. And our measure of academic performance in this case was the score in one section of the SAVER Pro test. There was no particular reason for selecting quantitative reasoning. I think that was a personal choice of mine because I really like quantitative reasoning, and I think it's always nice to have an indicator of such competency. But of course, another competency could also be selected. So this is the approach that we are suggesting, responding to our first objective. Basically, our approach consists of three major stages: the design stage, the evaluation stage, and the interpretation stage. And what we did in the first stage was to systematically train and test several models of neural networks. More specifically, we obtained 270 neural networks models. And this systematic process allows us to modify three important parameters of the networks, which were the learning rate, the momentum, and the activation function. So the rest of the parameters of the network were constant, so to speak, and we only changed these three parameters: learning rate, momentum, and learning function. one problem that has been reported in literature regarding the use of neural networks is that we still don't have like nice rules in order to, for example, test the quality or to assess the quality of the solution, right? Unlike the statistical techniques, we still don't know how to, for example, obtain a confidence interval of a classification, and we don't know how to make sure that our solution is stable over the time, and so on. So that's why we decided to propose this evaluation stage. And once we had identified the best model in the design stage, we decided to play a little bit more with that best model. So that's why we decided to test it again, that model 30 times. And we saw nice and interesting relationships between the quality measures and the error in each of these testings. And at the end, and in order to clarify a little bit more this black box conception of a neural network, we decided to carry out a sensitivity analysis. And basically, through a sensitivity analysis, it is possible to identify the predictive importance of the predictors that we selected. Probably you remember that we had several categories of predictors. So we wanted to show in a transparent way that when you develop a predictive system based on artificial neural networks, you can also identify and you can also determine which predictor is the most important, or which predictor is providing more information to the network in order to provide the classification. I think I didn't mention that, but it's quite important to understand that we organize our data set into two performance groups. So basically, our purpose was to classify the students belonging to the high performance group and belonging to the low performance group. And of course, this classification was made based on the score of the Saber protest. So what did we? What we found, sorry, in the design stage was that Sigmund function is a nice and an effective activation function for classification problems. So when we compare the results obtained using this function with the other two functions, we observed that there was no peak in the error function during the training, which was quite important because any problem during the training stage could be a problem during the testing stage, of course. We also noticed that this function, I mean Sigmoid function, converged more effectively towards the minimum of the error function. And remember that the general idea of this classification is to reduce that error function. So of course, we need to have like the best possible activation function in order to make this process the best possible process. We also observed that there was no relation between this function and the time of training. And I think there is also a misconception when you develop a predictive system based on neural networks, which is that the less time of training, the best or the better the quality of the classification, which is not the case, because the time of training is related to different aspects of the network. So even though there are different references which have suggested that, for example, sigmoid function is better because the time of training is less. We did not have evidence on this matter, so it wasn't that clear for us. And in the design stage, we also observed that it's quite important, of course, to deal properly with the issue of overtraining. Basically, the overtraining is when your system classify noisy patterns in the data set. So in the overtraining, you have a really nice performance during the training stage, but a really poor performance during the testing, and that is something that of course you should avoid when you are designing your neural network. During the evaluation stage, we found that it is possible to at least propose, for example, these confidence intervals for the error function. So after the 30 tests that we did, we were able to obtain sorry, these confidence intervals for both performance groups. And it's also possible to relate, as I told you before, the different quality measures and the error for each of the groups. And this was an interesting finding, because it is an evidence of how stable are the solution over the time. You see, because there is also criticism of the neural networks, because you can always argue that, yeah, if you train and test the first time the network, you can obtain a different result if you do it, I don't know, 15 times or 20 times later. And it's not the case. That is not the case, because we are showing that the solutions are stable, and that the relationship between the quality measures and the error in each of the groups is practically the same over several testings of the models. In the interpretation stage, we observed that there is a different behavior of the predictors within each of the groups, which was quite important and relevant, not only for this study, but also for my doctoral project in general, because this fact, sorry, is providing evidence of the nonlinear relationship between predictors of academic performance and academic performance. And I definitely believe that we should explore nonlinear approaches, such as neural networks, when we are analyzing academic performance in higher education. And as you can see, for example, if you compare the first two categories, prior achievement and parents SES, you realize that the predictive contribution, for example, in the high performance group, is different from the predictive contribution in the low performance group. So this is definitely providing us evidence that we need to consider not only prior achievement, not only SES, but also several other information related to students' characteristics, related to students' experiences, if we really want to understand what is happening with their academic performance. And of course, this result was then supported by the other chapters of my dissertation. And as you can see, we didn't have a perfect accuracy of the classification, but I will say that the accuracy that we obtained was satisfactory, 82% for the high performance group and 75% for the low performance group. And I had the opportunity to build predictive models using the same data set and working, for example, with logistic regression. And the accuracy in that case was lower than the accuracy achieved with the neural networks. So one might wonder, okay, why this value is not 100%? And possible explanation of that fact is that we didn't include any cognitive factor of the students. And our best proxy for the cognitive factors was the score in the Saber 11 test, the test that the students take at the end of high school. But of course, it would have been really, really interesting to have, for example, variables like working memory, working capacity, and so on. I mean, more cognitive information in relation to the development of quantitative reasoning. So that is something that we should explore in the near future. I mean, how the inclusion of these cognitive factors could increase the accuracy of the classification. So three simple and important conclusions of this study. We have shown that it's possible to systematically train and test artificial neural networks. And probably the invitation that I want to offer you is that I think there is a lot of research and a lot of work to do on this topic. I think it's quite important to begin and to begin to develop more clear and more generalizable sets of rules in order to design neural networks. We also found that the quality of the classifications derived from this type of models could be evaluated using error and performance measures. It's quite easy to assess the quality of this type of models. And we also found that prior achievement, SES, and high school characteristics continue to be weighted predictors of academic performance. And I think it's still necessary to understand at least how prior achievement and SES interact among them when we analyze academic performance in higher education. To finish my presentation, I would like to say that there are at least 4 important or 4 interesting subjects in order to continue with the research on artificial neural networks. We should definitely explore how to use these networks in order to develop predictive validity studies in higher education. There is a completely different approach, which could be really interesting to work with neural networks, which is the Bayesian networks. I didn't mention that, but this type of network is a supervised learning paradigm, which means that the network is learning from the examples, right? In every single iteration, the network learns from the output that we are showing to the network. However, there is a different approach of neural networks, which is the unsupervised learning paradigm, when we don't specify any input-output relationship. And I think there is a lot of work to do on this matter as well. How to truly propose and develop real predictive systems which don't require any output or any information on the output. And as I told you at the very beginning of the presentation, we decided to use like the most simple architecture, which was a neural network with only 1 layer. But of course, there are a lot of nice and there are a lot of sophisticated applications nowadays of neural networks of several layers, which is the deep learning approach. And I think the education research field could be benefit if we learn how to also develop these deep learning models.
First of all, thank you very much, Carlos, for your amazing presentation. Fantastic presentation. I like it very much. And I want to use this reactions button on the below the screen. So yeah, to make like applauses. Yeah. So you see from me. Yeah. Okay. And let's start the question section. And but before starting it, I would like to inform the audience how to ask questions orally. So below the screen, so on the bottom of the screen, you can see several icons, and one of these icons is participants. And if you push this button participants, you will see the list of participants, and below of this list you can see several options: invite, mute me, raise hand, and reclaim host. For instance, I can raise my hand now, and you can see near my icon, my picture, you can see raised hand. So if you use raised hand, I will see you and will provide you an opportunity to ask your question. And the second option, of course, is asking questions through the chat option, and I will voice these questions by myself. And as a chair, I have a nice option to ask first question. So I have two questions. They are mostly like not technical, but like research questions. So you know, so that there is the methodology of authors with the surname Intrator, you know, this Intrator and Intrator, and I think it was published something around in 2000, 2001. And these authors proposed the methodology to interpret the weights of input weights, generalized input weights, like in the same way as we interpreting regression coefficients.
Yes.
Yeah, and I was wondering, what is your personal and research opinion on this question, and would this methodology be useful for like for understanding the importance of predictors? And the second question, just to is that typically in neural networks we use random weights at starting point, right?
Mm-hmm.
So, and the question is how it, like this random weighting affects the predictor importance analysis in your work and in other works of the use artificial neural networks. So this is these are my two questions, and you can respond.
Okay. Okay. So I will begin with the first part of your question. I think you have to be really careful when you try to interpret the predictive weights, because even though the weights are representing the connections between the neurons in the network, you should not directly interpret these coefficients. That's why you have to develop the sensitivity analysis. Because through the sensitivity analysis, you can not only compare the category of predictors among them, but also you can normalize the predictive importance of each category. So it's not that straightforward to directly interpret the coefficients that you obtain during the training. So that's why you should go a little bit further and develop this type of analysis, the sensitivity analysis. And regarding the second part of your question, yeah, definitely you should always be aware of these random values that you choose for the training. And the problem here is that if you don't consider every single time different starting values, the system could show you a better performance, not because of better learning, but because of the same random value. I know if I'm clear. I mean, let's consider that you select the same random value in each iteration of the training. So the system will will show a better performance because it is always reducing the error function, but not because of a better learning. So that is why, and I think that we mentioned that this issue in the manuscript. Every single at every single iteration of the training process, we change the initial values of the training. So the network could truly begin a new learning process, a new, a different learning process each time.
Okay, thank you very much. So yeah, great responses. So, and we will start from questions in our chat. So I will voice them. So the first question is from Vadim. So Vadim is asking, you told about overtraining. Do you apply some methods of regularization?
Yeah, for sure. And I think that an important limitation of this study is precisely related to the way in which we handled overtraining, because there are several methods and several rules, so to speak, in order to deal with overtraining. Our approach was probably the most simple one. Basically, as we divided our data set into training data set and testing data set, what we did was always to verify that there was no overtraining, because if you revise the steps that we followed at the design stage, that is, I think is the figure 1 in the manuscript, you can notice that every single time we train and test every model. So our idea was to verify that there was no overtraining, that the quality of the classification was not affected by a possible overtraining. But of course, you have several other options, more sophisticated options. You can work, for example, with cross-validation data set, or as the person who asked the question is mentioned, there is like regularization techniques and so on. So definitely, I mean, there are better ways probably to deal with this issue of overtraining. What we did was to verify that there was no overtraining in the most simple way.
Okay, thank you. The next question comes from Anna. Anna is asking, did you benchmark the performance of the neural network model against the traditional statistical model on the same data? And what were the results of the comparison?
Okay, yeah. Thank you for that question. We did use, or I did use, like the logistic regression. And as I told you before, the accuracy of the prediction was low. I didn't include that information in the manuscript, but if I remember correctly, the accuracy of the classification was below 52%.
Mm-hmm. And that is why, so, this is like the reason behind your suggestion to use this.
For sure, that is one of the reasons.
You understand what I meant? Yes, great.
Yeah, for sure.
Okay.
Because
yeah.
No, as I told you at the very beginning of my presentation, the patterns of information in relation to students' performance are complex. The amount of patterns is increasing. So probably, even though a logistic regression is really powerful, it is not capable to identify correctly every single pattern underneath an educational data set. And that is one of the major advantages of the neural networks, because a neural network is able to learn of the data, but also to discover these patterns, because you don't have to be aware of the level of measurement of the predictors. You don't have to worry about the statistical distribution. If you only have nominal predictors, that is okay, because all that information is received in the input layer and then is propagated to the hidden layer of the network. And I think that that is the power of the neural network, the ability of identify and to understand those patterns of information.
Yeah, thank you very much. Next question comes from Ike, and he's asking, how did you collect predictor data, and is there any evidence of quality of that data?
I think I missed you guys. Can you hear me?
Yes, we can.
Okay.
And you, should I voice the question again?
Yes, please, because I think you mentioned something about the data.
No problem. The question is, how did you collect predictor data, and is there any evidence of quality of that data?
Thank you very much for that question. I think it's quite important. Well, as I mentioned before, here in Colombia, we design and manage these standardized tests. But here in Colombia, we have like a specific agency which takes part, or which takes responsibility of the Colombian Institute for Education and Evaluation, and this institute is responsible of designing the test, of applying the test, and so on. So when a student takes the Saber 11 test, for example, he or she should provide all this information regarding their SES characteristics, their high school characteristics, and so on. And the same happens when a student takes the Saber Pro test, the test taken at the end of the university. So even though this information is self-reported, we did have the opportunity to verify the information reported by the students. About the quality of the tests, well, these exams are frequently revised, and for example, the questions are adjusted and are modified when needed. And even though I don't have much information about the psychometrics properties of the Saber Pro test, I can tell you that, for example, the reliability of the Saber 11 test is quite high. It's not a perfect test, of course, but after every single application, people at this institute do their best in order to improve the test, to improve the quality, to improve the validity of the questions of the test.
Okay, thank you very much. The next question is from Ekaterina. First of all, Ekaterina, so I will just read it. Carlos, thank you for such an interesting report. Your study based on Colombian students. What do you think? Could the results be the same with the students of other nations? Thank you.
I think it's an interesting question. Probably not, because as I mentioned before, here in Colombia, we have this specific scenario of in higher education, which is that there is an important gap between private and public universities. And as I told you, those characteristics, for example, were included in this category of predictors, the university background. And as you can see in this graph, this category of predictors is providing or has an important contribution for the classification. 60% 16%, sorry, and almost, well, an 8.4% in the low performance group. I don't know what could happen in a different context. Probably this type of variables wouldn't be that important. I don't know, for example, in Russia, or for example, in a country like Belgium, I don't know. I would say that we could expect to find similar results in similar contexts as ours. I mean, in a country, I don't know, like Peru, like Ecuador, probably, but of course, I'm just guessing. So what I can tell you is that, of course, you can apply this methodology in any educational context. That's for sure.
Thank you. Okay, so the next question is from Anna. Your sample size was quite large. What would be the smallest sample size for the neural network analysis, given that you also need to train your network?
Okay. Well, I have seen, and actually, we have a recent publication, and I can send that publication to you, Dimitri, if you want to.
Yeah.
And in that study, we used a smaller sample size. The sample size in that case was 600 students from Argentina. And in that case, the accuracy of the prediction was impressive, was practically 100%. And the advantage in that case was that the neural network was able to identify every single pattern existing within the data set. And in that case, we also worked with this disproportion between the training and the testing data set. I think it was also 80 and 20%, or it was like 70 and 30%. So even though there is no a specific rule to partitionate your data set, the idea is that you always should have more information in the training than in the testing data set. But yeah, I think as long as you have enough data and enough cases, you can, of course, you can develop your predictive systems using neural networks. And as I told you, in that case, our sample size was really, well, not really, but was smaller, 600 students, and it worked just fine.
Okay, thank you very much. And the next question is from Vadim. He is asking, are there any methods to calculate the predictor importance other than based on sensitivity analysis?
To the best of my knowledge, no. But of course, my knowledge is quite limited, so I'm totally sure that there should be different ways in order to calculate that. We decided to work with sensitivity analysis because, as I told you, it gives you the opportunity to normalize the importance of each category of predictors, and to also to make comparisons among the predictors. But probably there are different methods in order to calculate the predictive contribution.
Yeah. Okay, I think that it would be like the way of responding the questions on the defense, like yeah, to the best of my knowledge, but okay. So, and the next question is so this is okay. Evgeny is asking. Okay, he had the same question as Anna about comparing results of artificial neural networks and other models. And I wonder, was the better quality the main motivation of choosing artificial neural networks? Okay, the question is, was the better quality the main motivation of choosing artificial neural networks?
Okay. Yeah, one of the major motivation was to increase the accuracy of the prediction. Mm-hmm. And in my particular case, I had the opportunity to work with a similar data set when I completed my master's thesis. That publication is also available if you wanted to revise that. And in that case, we used several multivariate techniques like MANOVA, multiple, logistic regression, multi-level analysis, and so on. And none of those techniques reported accuracy higher than 52%. So, of course, there was like a personal interest of mine in order to increase, to work to develop a better predictive system based not on the classical techniques, but on the neural networks in order to increase that accuracy. And from a general perspective, I insist the major advantage of using neural networks is the ability or their ability to identify these patterns of information.
That's interesting. Thank you. Okay, next question is from Vadim. Saber Pro is designed to assess general mathematical abilities. More generally, educational performance depends on the field and academic program, art, agriculture, and so on. What may be the approaches here? What about the imbalance of classes for different fields?
Okay. Thank you for that question. Well, Saber Pro test is designed to measure at least 5 different competencies, like the quantitative reasoning, critical reading, reading skills, English, and something that we here in Colombia call like civic competencies or something like that. So as I told you, there was no specific reason for selecting quantitative reasoning outcomes. It could have been another competency. And of course, it's not the same. It's not the same if you are studying law as if you're studying mathematics or something at the university. That's why, and I insist with this graph, all that information was included in this variable, in the university background variable, because there is recent literature supporting the idea that when you analyze academic performance in higher education, you should consider the academic program of the student, because it contains a lot of important information, not only about the learning experiences, but also the evaluation practices, but also the specific things that are happening in that specific field of knowledge. So, as we saw, it was quite possible to somehow have all that information, or to include all that information within this category of predictors, university background. We didn't have information about like the class size or something like that. So that type of information couldn't be included. But the predictive systems based on neural networks are quite robust, and it is possible to include that information if available. We don't have any restriction of level of measurement in this type of analysis.
Thank you very much. Okay, next question is from Anna. A practical question. To set up and run a logistic regression model doesn't take that long. How much time this research project has taken you, and in particular setting up the artificial neural network, training and evaluating the end model? Thank you.
Okay. Well, there is no like a perfect research tool, I will say. One of the probably disadvantages of neural networks is related to the time of training and testing. And particularly the multilayer perceptron. So I told you that during the design stage, we completed 270 different models. So just for you to have an idea, we were able to complete 10 models per day. So if we begin, I don't know, from 9 a.m. until 6 p.m., we were able to train and test 10 models. So of course, it's not the same and it's not that as fast as training or developing a logistic regression, but the results could be better. So my true invitation for you guys is to really consider the use of this type of models. And there are different approaches of neural networks, or better said, there are different topologies which are faster for training and testing.
Okay, thanks. Okay, Evgeny asking, what are the shares of these low performance and high performance groups in overall number of students? How many students are in these groups?
Okay, well, unfortunately, I don't have the precise number here with me, but I can tell you that the test contains like a specific performance descriptors. So the test is evaluated using a scale going from or ranging from 1 until 300. So in this case, we decided to work with the highest performance group, which is the group 4, students who obtain a score between 200 and 300. That was our high performance group. And our low performance group was students which had a score between 1 and 125. Unfortunately, and I say unfortunately because we wanted to have more students in the high performance group, of course, but the amount of students there wasn't that much in both training and testing.
Okay, I think that like one of the outcomes of our seminar today is like the increase of interest of the use of artificial neural networks for analyzing educational data, and I have like the first evidence for it. So Anna is asking, what software did you use in your analysis, and which one would you suggest?
I mean, there are a lot of options in terms of software. As we mentioned in the manuscript, used NeuroSolutions. NeuroSolutions is a... Oh, can you hear me?
Yes.
Yes, okay. So yeah, we use NeuroSolutions, which is a software developed by a research group in the University of Florida, I think. There is, like, as always, like the pro version, the student version, and so on. But of course, there are free options as well. For example, several packages in R have been developed in the recent years, like 2 or 3 years ago. And if you want to have like a more friendly beginning with the neural networks, you can always use SPSS, because SPSS allows you at least to develop MLP, I mean multilayer perceptron, and radial basis neural networks as well. These are like the 2 types of neural networks SPSS works with. But yeah, there are several options. It depends on what you want to do. But yeah, my suggestion will be to start probably with SPSS, and then go to another option like NeuroSolutions or Synapse, or yeah.
Mm-hmm. Okay, thank you very much. So next comment and the question comes from Daria. So thank you very much for the interesting presentation. Your article discusses such predictors as previous academic achievements, student economic status, and so on. These predictors are effective in predicting student performance in traditional higher education. What do you think of the use of these features to predict student performance in e-learning? In particular, to predict student performance in online degree. Do you think they will have the same predictive power?
Okay, I think that is a question for Dimitri.
Okay. Okay. But yeah, but my response is just we have to try. So it's like this.
Yeah, I
Why
mean,
not? Why not?
exactly. I mean, as long as we have a strong evidence that performance in online courses are a strong indicator or a strong measure of academic performance, we can always try to propose and to create the model. And there are at least three main categories of predictors, no, not predictors, sorry, of indicators of academic performance in higher education, which are achievement, competencies, and persistence. So I will say that performance in online courses could be understood as somehow like yeah, as an indicator of achievement. So why not? Yeah, as long as we have the data, if you have the data, we can proceed with the development of the model.
Okay.
And we have to compare. Yeah, I mean, everything is possible.
I also like such research collaborations. So let's discuss it further. Great, thank you very much for your response. And another question comes from Ivan. Ivan is asking another question related to comparison the results with baseline models. This is binary classification, right? 52% accuracy means nothing then. Isn't it strange that regression cannot classify students at all, even when it uses prior achievements, SES, and other strong predictors? Regression models usually outperform neural networks for n up to 10,000 and for around 100,000. The difference should not be that large too.
Okay. Thank you for that question, because of course the debate is totally open. I mean, regarding the use of neural networks over the classical techniques, and I want to be really clear on this matter, because the invitation is not to dismiss the use of the classical techniques, because that would be not only incorrect but also a little bit stupid, because we have seen during the, I don't know, the last 50 years or 100 years, I don't know, that the classical techniques are powerful tools in order to analyze educational data. I totally agree with the person who is asking the question that, yeah, we also have evidence, or we do have evidence that sometimes the classical techniques could perform better than the neural networks. In this particular case, in this particular data set, we found a better performance of the predictive systems based on neural networks than the classical techniques. That 52% is an overall accuracy, because if you compare, for example, the ability of the logistic regression to classify the students belonging to the high performance group, it could be higher. I mean, let's consider the confusion matrix of the classification. So we saw that the logistic regression was able to, for example, classify 85, 90%, correctly classify 90% of the students belonging to one of the categories, belonging to one of the performance groups, I mean. However, when you calculate like the general accuracy, I mean, the students who do belong and the students who don't belong to that performance group, the accuracy wasn't that high, as in the case of the neural networks, because the advantage of the neural networks over the logistic regression was precisely that. The system was able to correctly classify the students belonging and not belonging to each of the performance group, which was not the case for the logistic regression. And that's why the overall accuracy of the model based on the logistic regression was lower.
Okay, thank you very much. And the last question in our chat is from Ike. So he is asking, in Armenia, we have up-to-date data on all school students, including grades, some background information, school physical environment, and so on. This data is from education management system and schools are updating it online. Do you think your model could be applied to online educational data and analyze it in parallel with data collection process? And update from him. The data mentioned above is being updated every day, so it's kind of online data.
Yeah, I mean, my direct answer is yes, why not? I mean, because, I mean, the way in which we collect the data is not a problem, as long as it's data regarding predictors of academic performance, and as long as we have a true indicator of academic performance in higher education, we can always proceed with the development of the predictive model. In this case, given the nature of the data and given that the data is being updated like every single day, of course, we will have to take a decision. Okay, we will analyze the data every single month, every 2 months, I don't know. But the way in which collect the data is not a problem at all. As long as we can ensure the quality of the data, is possible.
Yeah, great. Thank you very much. Okay, so do we have questions, like oral questions from the audience? So because I don't see the raised hands. Okay, so I voiced all questions for you from the audience. So okay, and time comes to the closing part of our seminar. Okay, who? Yeah, one moment. Who raised hand? Irina. Okay. So Irina raised hand, but her not virtual hand, but her original hand. Okay, Irina, please ask your question. Welcome.
First of all, thank you very much for the presentation. Let me back to the question about countries. You use the data provided by Columbian Institute. Do you plan to broaden your research by using cases of other universities from maybe different countries and extrapolate the result to other objects? I mean that you use such predictors of academic performance as prior academic achievement, socioeconomic status, high school characteristic, and so on. What do you think? Can they be complemented by some other features that describe the specifics of learning in different universities, countries, and finally cultures? Because the learning styles and models may vary according to the cultural and national specifics. Thank you.
Thank you, Rina, for your question. And yeah, my answer is yes. I mean, first, it's possible to replicate this methodology in order to analyze educational data coming from other contexts, for sure. That would be really, really interesting, for example, to work with the data that was mentioned like in the last question. I think that the data comes from Armenia, if I understood correctly. And yeah, for sure, I mean, that would be great. I have been talking with some colleagues from Peru, for instance, because they also have a lot of information like national-wide, I mean, at national level in regarding academic performance in higher education. So I am really interested in trying to not only replicate the methodology, but also try to understand a little bit more about the results. And as I mentioned during the presentation, I will also like to include more information about cognitive factors, about learning styles, about assessment practices, because I think that unfortunately, we missed a lot of information regarding students' performance. Of course, it wasn't that easy, and it's not that easy to collect that information in such a large data set, as you can imagine. But we can always try to scale the problem, and probably it will be more interesting to have less students, but more information about those students. And that is why we did that in the study that I also mentioned before. We had only 600 students, Argentinian students, but we had a lot of information about those students. And the prediction was really, really good.
Thank you.
Okay. So, Carlos, thank you very much for this amazing, great, fantastic presentation, and especially for your live responses on our questions. I am happy with how we have done with this our first seminar, and I think this is a great start. And thank you very much for being with us today and for this amazing start. It's because of you, and of course because of the audience. Thank you, the audience, also for your great questions. I would like to wish you very successful defense.
Thank you very much.
And we are cheering for you with this obtaining the procedure of obtaining doctoral degree. Okay, and I would like to invite the audience to join me with saying thank you very much to Carlos. So thank you very much. Okay, do you want to say something at the end, Carlos?
Yes, for sure. First of all, thank you for your invitation, and I think it's always nice to share your work with such a fantastic audience. Thank you for the questions. They were really challenging and they were really interesting. And yeah, I really would like you to invite. I would like to consider the use of this type of tools in your research. And I'm always open to discuss, to interchange ideas, data, and so on. I think there is a lot to do regarding this area, and I think there is a nice future for using artificial intelligence in educational research. And I hope to join this seminar in the near future. I mean, you can always invite me for a upcoming session if you want.
We will do for sure every month, so you are very welcome. Yeah. So, and final remark from me that we are recording this seminar, and we will put this video recording to YouTube and to the website of the seminar to make a collection of wonderful presentations and talks. And I would like to say to everybody, to all our participants today, I wish you nice the rest of the week, and have a nice weekend. Thank you very much for being with us today, and see you in future. Thank you.
Thank you.
Thank you very much.